All right, hi everyone. What we're going to do today is continue our work in the quadratics. I'm going to give you a problem first to see how you guys think and if you can use quadratics to solve it. And then we'll look into graphing and then solving quadratics as well. Mainly reducing equations into the quadratic forms, and next week we will then move forward from reducing them to the quadratic form to then solving exponential quadratics. All right, so I'm going to put this question up on the board. So the perimeter of a rectangle, you may have seen something like this, is 20 centimeters. Just pin myself. So perimeter is 20 centimeters. And the area is 24 centimeters. I mean, you should be able to figure that just by looking at that, the dimensions of our rectangle. But I want you to use quadratics to solve for length and width. So this week and next week, we'll be going over theory of quadratics. Then the week after, I'm going to do some extra recordings in the holidays because these have been short because of my voice, which still hasn't recovered. But then the last few weeks, we're actually going to start applying this stuff to complex questions. So I'm going to give everyone 2 minutes to have a think. How could we use quadratics to solve this problem? Length and width from the perimeter and the area. Set my time for 2 minutes. All right, has anybody got something down? Any idea where we start? So first thing we should do is assign each of the variables to x and y. Length can be x, width can be y. Anybody remember the formula for area?
Length times width.
Yeah, or 2 bracket length plus width, or in this case, x plus y. And that is equal to 20. So that's the perimeter. We know the perimeter is 2x plus y in brackets equals 20. How would we solve for y? How would we manipulate this equation to be able to...
Substitute x.
Sorry?
Substitute x into the equation and solve for y.
So y equals 10 minus x?
Yeah.
So if we substitute back in now, we could do something like x times y. That's effectively what we're trying to solve for. Equals x to the power of 10 minus y. Should give us our eventual area. And then how would we simplify this? Any ideas? We would expand this first, wouldn't we? So we'd have 10x. Sorry, that's going to be x, not y. So we would expand the brackets to be 10x minus x squared gives us 24. What would the next line be? Remember back to our quadratic equation, has to equal 0. So now we're putting it into our quadratic equation. Does everybody remember what it was? A squared bx plus c. So we'd have x squared minus 10x plus 24 equals 0. And that's our quadratic equation. And remember when we did factorizing last week, how we factorize that back into the brackets? Give everyone a second to. What will we end up with? We obviously kind of know from the area what it's going to be, but anyone? We're just factorizing this. So this is how we can go from almost any equation, putting into our quadratic formula, or a squared minus bx plus 24 equals 0. We can't put anything into quadratic formula that we want, so as nice as that would be. There are some ways of doing it. And let's practice solving by putting everything back into it. Let's do need a new whiteboard. So we've got x to the power of 4 minus 7x squared. Does everyone remember our quadratic formula? Does that look like a quadratic formula? So now we're going from an equation and reducing it into our quadratic formula. So there's a couple of rules to be able to take something and reduce it into a quadratic. It has to equal 0. This number is a constant, meaning it's just a whole number. And we know that we can reduce that now because of those things. What we need to define is what is equal to u. So we need to reduce this because our quadratic formula, we need to make this squared. Now this is just equal to x squared to the power of 2, isn't it? So what we do is we get rid of this. And now we have a nice quadratic formula or quadratic equation. Depending, if your teacher's ever told you to convert u into x instead of x, or use u instead of x, it doesn't really matter. So we make this formula now. I'm just going to keep it as x. So how can we then factorize that? If we remember that we've got x. What can we factorize that down into?
X take 3, X take 4.
Okay. So we can, and this is all leading into some bigger stuff in the next few weeks, but we can take virtually any sum as long as it has, as long as we're able to put it back into the quadratic form, x squared or ax squared, whatever you want to talk about. 7x, you have a constant and then it's equal to 0. We can solve it as a quadratic formula. That was a little intro into that. We are going to, who remembers the basics of graphing quadratics? I think that was one you said, Molly, last week. Graphing quadratics.
Yeah.
So what I'm trying to do is put together like a picture in your mind so that when we get to the really, it's actually problem solving, like the perimeter question, that it all kind of clicks. So if I said to you, graph the following quadratic, y equals, I want to be nice, x squared minus, hopefully this works. Every time I step up in front of the class with the whiteboard marker, it never works. But any ideas where we begin? Remember that this is A, this is B, this is C.
You'd start with the 2 known, which is B and C, and then you figure out what A would be.
So
After that,
you can figure the easiest way to do this, because what we're wanting to do is find the x coordinate for the vertex. I'll show you a cheap way. So x equals minus b over 2a. So what have we got for B here? We've got we've got -4 for B. So we have over 2 times A. Because we don't have a number there, we assume it's 1. What would that give us? Give us 4/2. For the x, coordinate of the vertex is 2. Anybody want to plumb that back into the equation and find the y value? So we're finding the vertex of the parabola here. So we know if we graph quadratics, we get a parabola. Do we know what the vertex is on a graph? So if we had a graph, the vertex is the lowest point that the parabola will reach. So in this case, if we plumb the number, if we plumb 2 back into the original equation, gives us the y value. So y equals what's that give us? Four minus 8 plus 3. So -1. So what that tells us is this lowest point of this graph would be, well, let's just gonna roughly would be the x, y is -1. So if we're building a graph, the lowest point would be somewhere here, right? So now we find the x intercepts. So go back to our original equation. So how would we find the x-intercepts from this equation? Would we factorize the original equation? Flynn, how would we factorize the original equation? No pressure. So it'd be x minus 3, x minus 1. There's a concept when you're graphing parabolas, the 0 factor property. So we assume that x minus 3 equals 0 and x minus 1 also equals 0. So in this vertex, x would equal 3 and x would equal 1. So we assume on the x-intercept, sorry, on the y, because we're calculating for x, you would have 0. So we would have a dot here at 1, dot here at 3. Not to scale. Don't worry about my beautiful drawings. So how do we then calculate? We'll do a couple of these because I've got a couple of examples in my head. How would we calculate the y-intercept for this? We just sub in the numbers back into our original formula. So y equals 0 squared minus 4 times 0 plus 3. So would that just give us y equals 3 or 0 and 3? So somewhere along here. So our parabola would have a shape, something like that. I'm going to do this a couple of times. How do we know what kind of shape the graph will have? How do we know if it's going to be like that or the upside down smiley face? So if you have positive x, you'll get this shape. Negative x, you'll have upside down smiley face. But let's practice this and possibly even, yeah, let's practice this. So we'll go over time. I want you guys to sort of try and have a go yourselves. So y equals minus 4x squared minus 12x minus 8. So I'm going to give it again. We know this is A. B. So I'm going to give you guys a 2-minute head start. Try and do exactly what we did before. We find the vectors. I'll give you the x vector. Minus b over 2a. Oh, sorry, not the vector, the vertex. And remember, we have negative x, so remember the shape that your graph should be. Another trick the C term always the y-intercept. We'll draw a graph down here. Well, that's not 24. Wow. Well, thanks for that. So we'd have right -2. So the x coordinate of the vertex is -3, not -2, over 2. Another way we can write that is minus 1.5. So let's plug that back into our sum to find the y. So we know our x coordinate is minus 1.5. So we plug it back into the formula. So we've got minus 4.5 minus 12 I'll put 1.5. You can put 3 over 2. So that should give us y equals 1. So that's our starting point. So our starting point is going to be somewhere here. Wow, that's something close to that. Yeah. So remember, we need to find our y-intercept. And we have to assume that y equals 0. And this is where it's going to get tricky. So normally, we have a nice lead coefficient of 1. In this case, we don't. So we have to use a slightly different quadratic formula. So there are a lot of them. I'd suggest having a Google search and having a look at all the different quadratic formulas. This is very much an extension question. Don't even know if I'll let myself enough room. Well, actually, I'll do the like this first. So minus b. B squared minus 4 times a times c. So we're having, because it's not a nice lead coefficient of 1, we're having to rearrange the equation. And we do it like this. So this is the equation we use when we don't have a lead coefficient of 1. So if we sub the numbers in, we've got minus 12. So minus 12 squared minus 4. And then we've got minus 4 is A, 8 is C. Sorry, minus 8 is C. So a little bit of, we have 144. So we have 144. Then doing the brackets first. Grade 8 odd maths. Put it down here a little bit. Minus 144. Minus 12 times 1 minus, it's 12, not 144. So the power of 144 minus 128 over negative 8. Right, I'm just going to clear this off. I need a bigger whiteboard. So we've got 12 to the power of 16 minus 8. I can remember that. Oops, sorry, one blank there. So the reason that we have the plus and the minus sign, I could never remember the name for it. It's because we need to find both of the x-intercepts. So here, we've effectively got 12 plus or minus 4 divided by minus 8. So our first coordinate is 12 plus 4 divided by minus 8 is minus 2. Twelve minus 4 gives us 8. Divided by minus 8 gives us minus 1. So I deleted my sweet graph. So we've got our text there. So now we need to use those to find the y-intercept. To find the y-intercept, we just assume that x equals 0. And I want you guys to put 0 into this formula and tell me what the y-intercept is. So we assume that x is 0 for the y-intercept. What are our y coordinates?
wouldn't you have to solve it twice and have in the first one, so sub x for -2, and in the next have the same thing but sub x for -1?
But you're assuming on the y-axis that x is going to be 0. So regardless of what we actually found for the x-intercepts, you assume 0 is going to be the value of x. So you would do y equals -4. Because if it's on the y-axis, it has to be 0. X has to be 0. So you would then just have 0 minus 0 minus 8. Y equals 0 and -8. I can't imagine a time where you're not going to get a nice, what's the word? And we're going to do this again next week. But have you come across where you've had to use the quadratic formula doing graphing, or has it all been just factorizing? Because mostly it's factorizing, but every now and then you'll get faced with a question. And the way to decide if you need to use the quadratic formula or simple factorizing is, do you have a nice number 1 as your leading coefficient? I will see you guys next week and we'll continue with this. If there's anything in particular with graphing you want to go through, let me know and I'll incorporate it. I will see you guys next week.
Thank you.
Thank you.
See you guys. Sorry about my voice still.
Thanks, mate.